So to start with, what I'm going to have you do, so while you're looking at this, go through these next 2 pages and find where you have a blank piece of paper. And then on that blank piece of paper, I'm going to have you draw in a little flow chart to try to make sense of sort of what all of these bullets here in a second mean and how they work. So last year in Math 1, or whenever you did Math 1, you would have talked about, I think there's 2 L's in quadrilaterals maybe. You would have talked about the word quadrilaterals, and then we hopefully understand that this 4-letter prefix here, quad, implies a 4. So it's any figure with 4 sides. So any figure out there that has 4 sides to it, then that would be considered a quadrilateral, okay? So with that, off from the quadrilateral, draw in what we would call a parallelogram. This is what we've been working on here these last few days, is that idea. So sketch that in. And then we know these 5 properties. Okay, these are the 5 properties that we've been dealing with, that the opposite sides are congruent, opposite sides are parallel, those are the big ones. And then we also have like the opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. But then last year as well, you would have talked about, we can actually be a little more specific with a parallelogram. So draw in from one of these, draw in a rectangle. Because a rectangle is a parallelogram. If this is a parallelogram, a rectangle has all of the properties of a parallelogram as well. So opposite sides are congruent, opposite sides are parallel. Okay, all the 5 properties that we would have been dealing with here, opposite angles congruent, opposite angles supplementary, diagonals bisect each other. A rectangle has all of those properties as well. Next, draw in over here though. I'm not sure I can draw this real good, so bear with me here. Draw in, as best you can, what is called a rhombus. And what's unique about a rhombus is that it's a parallelogram where all of the sides are congruent. But a rhombus is still a rectangle, so all the properties of a parallelogram also apply to a rhombus. And then at the bottom of this flow chart is, if we combine these principles, the principles, and we're going to go over some of them in detail in a second, of a rectangle and a rhombus, what we ultimately then end up with at the very bottom is a square. So because this is a square, then our square here has all the properties of a rhombus, it has all the properties of a rectangle, it has all the properties of a parallelogram. Okay, so anything bottom, a rectangle, rhombus, square, it shares all of these properties as a parallelogram. With that flow chart in mind now, you got a lot of new properties to look at here. So go to this now in our notes. So go to the 5.8 or just look on our screen as we go through these. The first ones we know. So this is what we spent the last couple of days on. In a parallelogram, here are our properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and consecutive angles are supplementary. So that's stuff that we've been dealing with the last couple of days. That's largely what the homework was on. In many ways, those are the things you would have just done on that little quiz that I gave you, okay? So that we know. When we go to a rectangle, since the rectangle lies underneath the parallelogram in our flow chart, then we can say, since this is a parallelogram, that all the properties of a parallelogram would apply to a rectangle as well. All right? Yes, that's my dog barking. Sorry, he's locked in the room. All right, so all the properties of a parallelogram are going to apply. So all of these guys here also apply to a rectangle, but we also have a few unique properties to a rectangle that don't apply to a parallelogram, and that is all the angles are right angles. So this angle here is a 90, 90, 90, and then 90. And then your diagonals are congruent. So this diagonal and this diagonal are congruent. That's if we're dealing with a rectangle. All right. When we go to a rhombus, because it lies underneath a parallelogram, on our flowchart, all the properties of a parallelogram apply. But now we have to add some. And here's are the ones that we're going to be adding. That the two pair can actually, in 2 and 3 kind of go hand in hand. If we look at these together, all sides are congruent in a rhombus. So that's why 2 consecutive sides are congruent. So all sides are congruent. The diagonals bisect the angles. So that's a big one. So this diagonal right here means that this angle here and this angle here are congruent. And this angle here and this angle here are congruent. The diagonals bisect those angles. Number 5, the diagonals are perpendicular bisectors of each other. So we've talked about diagonals bisecting each other. So this segment is congruent to this one. I don't want that. And then this segment is congruent to this one. So they're still going to bisect each other, but they're also perpendicular to each other. So in a rhombus, this has to be a 90-degree angle because they're perpendicular and they're cutting each other in half. And then 6, the diagonals divide the rhombus into 4 congruent right triangles. So what that means is if we look at these triangles in here, so here's one triangle, here's another triangles. I'll leave the other 2 white. Well, all 4 of these triangles, all right, the 2 yellow ones and the 2 white ones, those are congruent. So same length, same angles, same area, all that good stuff. All right. We're going to stop right there before we add even more with a square. What I want you to do is jump down to problem number 1 that deal now with these 2 properties. So for example number 1, what we're going to do is find the missing angles of this rhombus. So all of these properties that we just talked about in a rhombus, we're going to use to figure these out. All right. So when we look at this first problem, all I give you is that this angle down here is a 35-degree angle. We should be able to come up with all of these other angles. All right. So let's dive in here. We'll kind of go through this one together. And if you have time today, I'll have you do number 2. If not, we'll have you try number 2 tomorrow. So in a rhombus, first and foremost, a rhombus is a parallelogram. So what that means is opposite sides. So this side here is parallel to the opposite side down here. So these sides are parallel to each other. So one of the things that we've had a hard time seeing when we've had people in class, we're able to kind of walk around over the last week or so with this, is that when we have these parallel lines, when we start having these transversals drawn in, but we have more than one transversal, we're not necessarily seeing that this angle here is an alternate interior angle to this angle here. All right, they're both inside of the parallel lines, and they're on opposite sides of that transversal. So because of that, what that allows us to then say, opposite interior angles are congruent. So angle 4, I'm going to cover that up, and we now know angle 4 has to be a 35-degree angle. All right, and then we're at least on our way in terms of getting some of these angles marked. All right. From there, the only way we can get after the next set is with these new properties of a rhombus. We wouldn't have known enough yesterday to be able to start to find 1, 2, 3, all these other angles. So let's go back up to these properties of a rhombus, and there's a couple that we could use, but the one that I'm going to have you use in a rhombus, let me clean all this up. So far we just used one of these properties, but the one I'm going to have you use next is number 5. So if we look, the diagonals are perpendicular bisectors of each other in a rhombus. So let's go back to our rhombus. Look at your diagonals. So we have one of them already drawn in. Let me draw in the other one. So here comes this diagonal. They bisect each other. So we know this segment and this segment are congruent, and then this and this are congruent. That we've known for a while. but they're not simply bisectors, they are perpendicular bisectors. So that means that the angle that they form right here with each other has to be a 90-degree angle. So then that would mean that this is a 90-degree angle. Let me do the angles in the black here. So this is a 90-degree angle. That means angle 8 would have to be a 90-degree angle, and angle 9 would be a 90-degree angle. If we don't know those properties, you wouldn't necessarily have known that. That's why we want to know what those are. All right. Real quick, now that we have those, I would think we could get a few more angles. So take 30 seconds here, and we should be able to come up with a few more angles. So take a second and write down what you think you could do next. All right, and anybody on a path that would allow us to figure out one of these other missing angles. So angle 1, 2, 3, 7, 6, or 5. Anybody got a path to get one of those? Because we should. So if you don't, then I don't believe you. Yeah, Dahlia, what do you think? Which angle are you going to go for, Dahlia? Good, perfect. So she's talking about angle 7 down here. What she's talking about is we have a triangle that I just shaded in. All three of those angles have to add up to be 180. So way back in our first unit, or first section in this module, 5.1, that's what we would have talked about. So what she said is she knows this whole triangle has to be 180. So let's subtract away the two angles that we now know. What'd you get, Dahlia? Did you do that yet? Good. And then Alexis threw that out there as well. So good, you're both correct. So what we would have left over down here is a 55-degree angle. So with that in mind, couldn't we also come up here and do something pretty similar? Actually, there's a couple different routes we could take now to figure out angle 3. If we go with Dahlia's thinking here, then we also have a triangle up there, 90, 35, 180. Wouldn't that really just set up the exact same little mathematical work down there? 180 minus the 90 minus 35, that's got to be 55 as well. But also, isn't this angle an alternate interior angle to this one? So once I knew this was 55, this must also be 55. All right, good. The next ones, though, we have a bit of a problem. So if we look at the two remaining angles, or triangles, and/or angles, I suppose. So angle 2 and angle 1. Yeah, this is a triangle, but we can't do what we just did because we only know one of the three angles. So what we just did will only work if we knew two of them. So the only way we can get angles 1, 2, 5, and 6, let's revisit our properties here, in a rhombus. And the one you're going to want to look at is this guy right here. The diagonals in a rhombus bisect the angles. Right, so the diagonals bisect the angles. So let's revisit. Remember what diagonals are. They're the red lines currently that I have drawn in. They connect one vertex to the opposite vertex. So this is a diagonal right here. So what that property is saying is these diagonals cut the angles in half. So this big angle that would have been formed by our original rhombus should be getting bisected, should be getting cut right in half. So if that is going to get cut in half, Anybody think they then know what angle 1 would have to equal? Because that should allow us to figure out what angle 1 is, understanding that. Any thoughts? So if we know that this diagonal here is cutting this big angle in half. So the big one that I'm shading in right now just got cut in half. We know what angle 1 has to be. Nobody? Throw it in the chat here. Yeah, Dahlia? Oh, you're getting warmer. But 35 is just this guy. Uh-oh. I might be finishing just in time for my computer dies. 35 is just the little angle, correct? So it's actually kind of the opposite of what Dahlia said. What would we want to do to that 35? We wouldn't want to cut that in half to figure out. Yeah, so this, you dog, you. This is not my day with this thing. I don't even know what page you're on. So if this is 35, then this full angle right here, wouldn't that full angle had to have been 70 degrees? If, what the, now it just disappeared on me, Mr. Kubitz. You see that? Yeah, and that's still there. See, all you late people, I was having a hard time myself. All right, so let's finish with this. So here was the diagonal. We knew this angle was 35. So if this diagonal is cutting the bigger angle in half, wouldn't this also have to be a 35-degree angle? That would have given us that full 70 degrees that we knew the whole thing was. And then when we cut in half, we would have 35 here and then 35 right there. Then, real quick, you hopefully have your graph, didn't disappear off your paper. Isn't this angle then an alternate interior angle to this angle right here? So I don't remember what number this is since it's disappeared, but I know we hadn't found that one yet. But we now know that that angle also had to have been a 35-degree angle because they're alternate interior angles. Or we knew this was 35 and it was the same thing. That diagonal should have been cutting it in half. All right. And then the last one, we had this diagonal drawn in here. We knew this was a 55-degree angle. This was a 90 and a 90. So now we have a couple of options. We could go back to the whole triangle idea that if I know this whole triangle has to add up to be 180, the angles inside, then you can just do the 180 minus the 90 minus the 35. That means this has to be a 55-degree angle. Or didn't we say our diagonals bisect the angle? So this big angle here should have been cut in half by that diagonal. So if this was 55, this would have also been 55. All right, and then the last one, same idea up here. You can do one or the other, alternate interior, or do your triangle sum theorem. All right. And what's weird, Mr. Kubowitz, the type and words on the other pages are still there. Just there. It's really odd. Who knows? It's the end of the class anyway, so no need to worry too much about it. So that's example 1. Bring this tomorrow. We'll go to example number 2, and then we'll hit on, there's even more properties, right? We kind of skipped the square. We skipped what's called a kite. We skipped what is called a trapezoid. So we'll throw some more things out there for you tomorrow to cloud your mind and give you more things to memorize, all right? If you don't have the homework done that was due tonight, please get that uploaded. We don't have anything with this section. We'll wait until tomorrow until we get it all done. All right. All right. With that, we'll say goodbye. All right. Have a good night. We'll see you guys tomorrow. Bye. Yep, bye. Right. It just was gone.